Hello, everyone, and welcome back to the day 2 of the free week of lessons in software quality assurance testing offered by the Skillrail Academy. Yesterday, we talked about software testing. We looked into the interview questions, tricky interview questions, where you're asked to test a particular object or an application. And interviewers will try to see if you understand the correct sequence of events in software testing. So it is so important to understand the product, the application in our case, first, to learn about the application from the requirement documents before you jump into testing, before you start coming up with test case ideas. Okay, so that is so important. We also looked into a test management tool called Azure DevOps, and we created our first test case. That's a good step for us. Okay. Apart from that, we looked into generative AI, ChatGPT, to create ideas for test cases. As I explained yesterday, so this tool, this additional technology that we have in our hands right now, it is very useful. We should be using it, utilizing it as much as possible during our learning process and afterwards during your job hunting process and later on when you actually start working. Okay, so this is very important. All right, so with that being said, let's move on and take a look what we're going to learn today. So we have been introduced to testing yesterday. Today, we're going to look into an important and very interesting topic of bugs, defects, issues, failures, errors, right? Whatever you can relate to having some issue in the software. So that's going to be interesting. Tomorrow, our topic is going to be SQL. So make sure you don't miss tomorrow's lesson as well. If you are good with Microsoft Excel, if you're good with numbers or filtering numbers, let's say organizing the numbers in spreadsheet applications such as Google Sheets or Microsoft Excel, so you're going to love SQL basically. So don't miss that. Day 4, you're going to write your first line of code in Python. And as I mentioned earlier in the previous session as well, test automation has become more and more in demand in all of the organizations that we know. That's because everybody's trying to be more and more efficient so that they can save time, so that they can be faster, and they can achieve what manual testers do, or for most of the manual work, with automated scripts. Okay, so that's something that we're going to look into during day 5 as well. So I'm gonna show you how to interact with the browser using Python scripts. Okay, so you will be able to open the browser, go to a specific web page, and perform operations, actions such as clicks or enter some text, or refresh the page in that sense. Okay, all right, so with that, let's take a look what kind of questions we will be answering today together. We're going to try to keep it interactive, and I want everybody to participate actively. Okay, so together we're going to answer the question. So what is a bug in your understanding? And I'll give you the official definition as well. And we will also discuss, where do the bugs come from? Where do they come from? Why do we have them? Who fixes the bugs? So which role in the organization, in the IT team, will fix the bugs and who will not fix the bugs, right? So we need to have this clear distinction so that so that we understand which party or which team is responsible for which part of the software development process. And also, why is it important to prevent the bugs earlier, right? Why is it important to prevent the bugs rather than detect the bugs? There's a difference. You can prevent it, and if you don't prevent it, then you're going to have to spend time in the future to find it and to remediate it and close it. And why is that? We need the testers. That's another important question. Why is that we need the testers? Why can't developers test their own code? That's another interesting question that we can answer. Also, one of the mostly asked or most frequently asked interview question is that what if developer will actually reject your bug report? So developers can actually reject your bug report. So you can report saying, hey, I see some issue, but they can say, well, I don't think that's an issue. So that's a common situation in IT industry or during the software development process. And therefore this question comes up a lot. Okay, so we're going to discuss all of this one by one after another, but let's start with a fun fact that the first computer or first software bug was actually found in 1947. Let's say it was recorded, or a specific note or evidence was taken of her first actual bug. In 1947, it was at Harvard University Computer Lab, and the fun part is that it was an actual moth stuck inside the computer. So it was actually causing some malfunction, and then they had to dig into the hardware, and then they found this creature, and then they took it out, and that was the cause, and they took a note, like we always do. Testers, when you find a bug, you take an evidence of the bug. Okay, today actually I'm going to show you how to take an evidence using a snipping tool. Take a screenshot and then attach it to your bug report. So just like that, the screenshot that you're seeing here is a bug report, but it was the actual bug. All right, so here's the part where I want everybody to be more active and then put your answers into the chat. What is a bug? What do you think the bug is with your own words? Okay, no official definition. You don't have to look up. Well, feel free to look up from the internet as well. That's absolutely fine. Okay, so we have some answers already. You guys are quick. An unexpected income to an input. That's a great explanation. So it's you get some unexpected, right, outcome to an input. So when you interact with the application, yes, you are here to input some information. You input some data, and then you expect some output. But then if that output is unexpected, right? If it doesn't match what you were expecting, then that's what we call as a bug. All right, bugs means, I keep reading your answers. So bugs means the defects or faults in the application. Good. Another answer, unexpected outcome. That's a popular answer. An error. That's something that you can say, yeah, bug is an error. It's a mistake. Okay. Another person is saying error, defect in software application. Something that caused the application to have errors. That's interesting, right? So it's not the actual error, but what's causing the error, right? That could be there could be a slight difference there between the error that you see on the screen and then what was the root cause of that error. So bug is an issue, a mistake missed by the engineers. Good explanation. While testing the requirements and generate errors, coding error, and it's a difference between the expected and actual result. Here's a very very nice official explanation as well. So everybody, great answers. I like it. And you guys are very active. That's a good thing. So here's the explanation. Very close to what you just gave, actually. So bug is an unexpected behavior in computer software. That is right. It's unexpected because, as we discussed yesterday, when you start testing, you have some expectations. Where do you get your expectations from? You get your expectations from a requirement documentation, right? Like the example we saw yesterday, functional requirement document, or any other, like a business requirement document or technical design document. So any document that gives you an idea about what users are expecting from this application. So you have some expectations when you start testing. And what you do is that you start comparing your expected results with the actual results, right? The expected behavior with the actual behavior. And then when you see the differences, that was unexpected, right? So therefore, bug is an unexpected behavior in a computer software. And you can say it's a defect or it's an issue. Those can be used interchangeably. Here's another explanation. I think I saw one of the participants or two of the participants gave a similar answer. It's a difference between expected conditions and the actual results, right? So you have conditions that you take from the requirement documents, such as if I click the login button while the username is missing, you are expecting some error message. So the application should be smart enough to tell you, hey, you're missing a username. Well, if you click the login button and then you have incorrect username and password provided, then the application should be smart enough to tell you username and password combination did not match, right? And some applications actually is going to lock you out if you try it several times, right? So there should be a limit for your incorrect attempts or tries as well, right? So bug is the difference between your expected conditions. So you were expecting a welcome message, but you received an error message instead saying, hey, oops, something went wrong, or the page not found. I'm pretty sure you have seen such error messages before. And that's what you report. You report the difference as a bug report, right? So we're going to see how to create a bug report in the same application that you saw yesterday. All right, here's another question. Where do bugs come from? You actually partially answered. I know that some of the students today already answered to a certain extent this question, saying that it is a mistake that developers make. That's a correct answer. Yes, that is a correct answer. So where do bugs come from? Well, developers make a mistake, right? So that's the that is fine. So there is an issue in the code or integration issue. All right. So one of the participants just mentioned that bugs come from integration issues. Yeah, that's absolutely possible. Especially nowadays, all the applications that we know in real life, they don't work in isolation. So applications work in integration. They provide some information to one another. Just think of Facebook and Instagram, for example, right? Instagram used to be separate a long time ago until Facebook purchased or acquired Instagram. And nowadays, whenever you post a story, let's say in Instagram, that story can actually go to the Facebook page as well, right? The same thing with the post. You make a post and that can go to the Facebook. So this is an integration. That's what we refer to as an integration between applications. Okay, so let me see some of the additional answers from the chat. So users are saying business people can miss some requirements. Excellent, yeah. So that's what we refer to as a requirement documentation related issues, right? Documentation related issues. So you rely on the documentation, right? When you test, you rely on documentation. When the developers also code, they also rely on documentation that was provided by the end users. So sometimes we refer to them as business, right? Business group or business users. If they created incorrect documentation or they missed important parts of the actual requirement, then obviously everybody made a mistake. Then after that, developers coded incorrectly, and then you accordingly you might find an issue. You might come across to a design issue. All right, so for some more answers, human error due to change or updates. That is correct. Yeah. Okay, so now let's take a look at this workflow that's probably gonna shed some light into how bugs come into picture. So software developer makes a mistake while coding. So this example that we're giving you is a coding issue, basically, right? So root causes can be different. There can be many different root causes, but the one that we're looking into right now specifically is coding related bugs. Okay, so developer makes a mistake while coding. They can fall asleep. Maybe they are too tired. They've been working, straight for many hours, and maybe they are burdened with several projects at the same time. So they are now doing some defect fixes for one application, but at the same time, their manager gave them another application to develop. So they are multitasking, and then they made a mistake. Okay, so there could be many reasons. So it's a human error, just like you guys mentioned. So developer makes a mistake while coding. That mistake actually leads to a new bug in the application. Okay, so it leads to a new bug, and the bug can be they missed a semicolon or they missed a parenthesis somewhere when they were coding. Instead of just putting like a one equal sign, they put double equal sign or the other way around, and that results in a failure. Failure is the actual error message that you see as a user, as a tester, that when you interact with the application, that's what you see on the screen. Okay. This can be an interview question as well, so it can come up as a question saying, do you know the difference between the error, bug, and a failure? And here's an important information to you, by the way. Yesterday, we talked about certifications, and I highly recommend each one of you to explore ISTQB certification. When you get a chance, you can do it in parallel. This information that you are seeing on the screen actually is in line with the ISTQB requirements or ISTQB guidelines. So it's one of the questions in the test as well in ISTQB. Okay. All right. Now, here's a question to everybody again. Guys, be active, participate. Who fixes the bugs, right? So which role in the organization fixes the bugs? Here we go. Quick answers, developers. Absolutely right. Software developers, dev. Excellent. You guys are fast. Right. Let's start from who will not actually test, right? It will not actually fix. So that would be the testers, right? So not the testers. We don't fix. That's not our job. So software testers' job is to test and report the unexpected behavior in the application. Okay, so unexpected behavior, that's what we notice. That's our job. to compare the requirements against the actual behavior of the application and then report the differences. So we don't fix. That's actually good news, because the fixing would be a lot harder and much more complex, actually, because they are supposed to do a root cause analysis, right? Developers actually would investigate the bug. They perform root cause analysis. That means they need to spend time to go back into the code and then analyze and then see where exactly that particular bug is hidden. What went wrong when they were coding, right? So they need to find this missing parenthesis or semicolon, or maybe instead of putting like a greater than sign, they put greater than equal sign. So basically, they need to dig into this. That's what we call as a root cause analysis, and they fix it. They let the testers know. They basically provide you a new version of the software. Okay, that new version of the software, we refer to that as a build, like a building, right? So, but but in simple terms, it's just a new, enhanced or fixed version of the software. Have you ever noticed that whenever you get an update for any application on your mobile phone, you get a new version, basically, right? So, and then there's a release notes. There's such thing as a release notes. They tell you, okay, as part of this update, certain minor bugs were fixed. As part of this upgrade, now you're getting a new enhancements, new features, new functionalities, and so on. So those are the builds. That's what we refer to as a new build or a new version of the application. That's what we expect from developers, basically. Okay. Again, if you just compare the overall effort that's put into testing and into development, developers do a lot of hard work. Okay, so testers, your job is easier, especially if you're in manual testing, especially if you're performing more of a functional testing through the graphical user interface from the front end of the application. Then your job is more like a common sense, So I always say that you don't need a degree to be a tester. The degree would be a waste, actually, too, if you just perform testing. Because anyone with a common sense can perform testing. With some analytical skills, you can certainly do that. Okay, here's another question. Why can't a developer test, right? So they created their code. They know their own code. Why wouldn't they just go ahead and test? Why do we need the testers? What do you think? Okay, here we go. So there's one answer, bias. Here we go. I like that answer. You so right to the point. Time. That is also correct. Yeah, time. So their time is actually more valuable. I gotta tell you, most of the time, the hours that spent by the developers are actually more valuable than the testers. And here's another answer, conflict of interest. Yes, conflicts of interest. That's right. So one person is developing, another person should be testing. And here's another good answer, doer and checker. Right. There are those who make it, and there are the other ones who check it, right? Makers or checkers. So good answer. And want to see from the other point of view. They want to see from another point of view. That's correct. Yes, that is correct. And they can see from another point of view. Okay, here's another question. There was another question. Was it a live session? Yeah, this is a live session. We're in a live session right now. Okay, developer is not so critical to his work as others. That is correct, guys. Thank you for your active participation. I like the answers. You guys are good. So, as one of you already mentioned, developers would be biased as a creator of their own work. That's absolutely normal, actually, as a human being. When you create something, you have put so much effort. It's very unlikely that you would be expecting a lot of defects, because psychologically, if you think, defects would mean extra work for you. It would mean that you didn't do your work properly or as per the standards, and you don't want to think like that, right? Developers wouldn't want to think like that. Obviously, if they test, some of the obvious defects would come out. Like if they were trying to log in and they can't even log in, that would be a shame. So that means that they just didn't do a good job at all, right? So they can still catch some of the obvious bugs, but they wouldn't go to the extent of uncovering all the hidden bugs, or as many hidden bugs as possible. Okay. Now, testers, on the other hand, are being paid to test, right? That's their specialty. They have been testing again and again so many applications, maybe in the same industry or similar applications, right? If you're testing a banking application, if you tested one mortgage application, next time you test a mortgage application, you know what to test. You know where things might go wrong, right? Maybe you should be testing the field with negative numbers, maybe with a huge number, right, beyond the maximum integer, and so on. So experience is an important concept, other than testing objectively, right? So testers obviously would test it objectively. Also, it's a good quality for a tester to have, to be able to put yourself in end users' shoes. Okay. So when I say this, I know we're not just writing those on the slides just so to fill up the slide. So when I say put yourself in end user's shoes, that means more than just sitting at your desk and imagining that you are an end user. You're going to have to arrange calls, arrange a meeting with the end user, talk to the users, right? Be close to them, understand how they use the application. What are their expectations? You read the requirements. Why don't you have a meeting with them? Why don't you have a call with them, sit together and discuss what you understood and what their understanding is about the requirements? Think of it that way. Requirements are also like just a document that's created by human beings. Now, do you expect them to be perfect and they just put everything they want in a documentation? No, right? So there are written requirements and there are unwritten requirements. So they're also lazy enough to not to put everything in the requirements, okay? So they have a lot to do. They're the business people. Maybe that person is a mortgage specialist. Maybe, a manager at a bank. And they had some time, they were asked to create a documentation, they create the documentation. Maybe something new came up after they created. So you need to be in close communication with the end users. That's important, okay? Of course, there is a role in IT group that what we refer to as business analyst. That's a job of the business analyst to communicate more with the end users and to create the functional requirement documents. But keep that in mind. Not every organization has a business analyst. Not every team has a business analyst, or they have money to pay the business analyst. So you may have to be more proactive and then talk to the end users. That's how you put yourself in end user shoes. That's how you objectively test. Okay, because that's your job. Again, as we said, your job is not to fix. Your job is not to dig into the root cause of the bug, but to test and to actually find the bugs, right? Okay. With that, let's move on. Here's another interesting question. Why to prevent the bugs early, right? Why to prevent it? Or why to test early? So why do you think it's important to prevent the bugs rather than letting them happen and then finding them later on? Okay, so let's take a look at the answers. First answer, save money. Yes. And another answer, it may cause bigger issues in the future. And I see several further great answers: to reduce the cost, save time, less backtracking. That's right. Yeah, deliver high quality product to the client, and it's going to turn into a lot of work. Yeah, that is true. That is true, guys. To meet the expectation result, it may affect the schedule. Let's talk about the schedule too. Yeah, you guys are right. So, as most of you mentioned, it's closely related to the cost. Okay, it's closely related to the cost. So, because the bugs that are missed and found later rather than early, right, was going to cost a lot more in terms of money and reputation to the company. Okay, so as you can see, if the bug that was discovered later on in the software development process, think of the software development process is like a whole life cycle of building a product. Think of Toyota building a car, or any construction company building a building, any like an office building. They would have to go through several steps. They do the sketching, right? They have some documentation where they describe the design and how they're going to approach with constructing or building this particular model or or product. And then following that design, someone will actually perform the actual building process, and then someone will test it, right? There will be a testing phase and utilization phase all the way, right? Throughout all this process, the same life cycle basically applies to software development process as well. Okay, in software development process, the same thing. End users, they create the requirements, and then following the requirements, developers code, if we just simplify it, and then we test, right? And then users also test, accept it, and then it just goes to the utilization, to what we call as a production. It goes live. Okay. Now, if the bug was missed all the way along this chain of events and it was found at the end when it's already being utilized, right? That's going to cost like 100 times more, if not more than this, than if it was found earlier. Okay. That's what we also refer to as a shift left testing. Okay. So talk about this during the interviews, guys. When you go to interviews, make sure you use every chance to be able to demonstrate your knowledge in important topics like this. Okay, so shift left testing, or finding or preventing the bugs earlier in the software development lifecycle is very important for every company. Okay, now let's see some of the examples of how the bugs that were, or the issues that were found later, right? That was not prevented, and it ended up being at a lot of cost to the companies. So this particular example comes from NASA Spacecraft that crashed basically within 5 minutes after the launch, right? That happened 1962, and you would be surprised to understand or to see what the root cause was. The root cause was like one of you actually earlier mentioned, documentation issue. It was a documentation issue. That's a great example that you can give to anyone, basically. So in the design document, instead of R bar, right? You see there's a R bar. Don't ask me what exactly that means. It's, I don't work for NASA. So instead of the R bar symbol, whoever who was putting together this documentation, they used the regular R. They used the regular R. Maybe that was printing it. It was a printing issue. Whatever it was a documentation, and all the design was done based on this. They took that into account, that R instead of the R bar symbol, and that actually caused the crash. That costed in today's terms like close to what, $200 million. Okay, so even though everybody did their job perfectly fine, developer designed, everything went well. However, if there was an issue with the documentation, then everything might eventually collapse. Okay, so that documentation should have been carefully analyzed by subject matter experts, by the author, and by someone else who also specialized in this industry again and again, and this should have been prevented. Okay. Bugs in banking applications, right? So financial industry, that's part of our life, and most of the people I know who graduated from boot camps, they work in financial companies, financial institutions like banks or hedge funds, and those applications are also prone to mistakes like this, that as you see. So they accidentally, let's say one bank accidentally deposits $50 billion. Okay, and obviously it's not so easy to handle the situation later on. If you hear something like this, and you would start losing trust in that application and in that particular financial institution. Here's another application, but example, but this is from the crypto platforms. Crypto applications has become very widely used by the general public for the past, I would say, what, 8-10 years. And as you can see, there are some of the examples here that crypto platform accidentally sending $7 million instead of $68, and then suing the users because they started spending it and so on. So all of this could have been prevented. Again, that is the result of a poor testing or overall poor software development process, or rushing into the market with a new build and so on. So those companies who actually lost reputation, lost a lot of money, they definitely will be very careful in the future, and they're going to pay a lot of attention to have a good team of testers within the IT department. Okay, so who are independent, who can objectively test, and so on. All right, so that brings us to the topic of bug lifecycle. So when the bug is found, as a software tester, when you find a bug, it goes through several stages. The bug says a status. So it can be in an open status, it can be in a fixed status, and it can be a reopen, and it can be closed, and so on, right? There are different labels that bug can have throughout its life cycle. So that's something that we're going to look into together. So the first step, of course, would be, as a tester, you find the bug, right? You found your first defect, your bug report, and here we go. That's a happy moment. I found my first bug. I'm useful in this organization. So at that stage, the status of the bug is new. Okay, it's a new bug, basically. Simple. So as I mentioned several times yesterday as well, do not overcomplicate things in your mind. When you think of software testing, there's nothing complex in it. Try to simplify everything that you are learning. Okay, you found an issue, that's a new bug. Then what happens to that new bug? Development team, right? Someone from the development team, usually a lead developer, is going to analyze the bug, look into the bug in the system, and they will come to a conclusion. They need to come to a conclusion whether to fix it or to reject it. If they think it's not a good bug report, it doesn't sound like a bug, but it sounds like something that you're just recommending. Maybe you just think it's a bug, but it's not really a bug. This is how it's supposed to be. So, and it happens from time to time, and this is actually one of the frequently asked interview question, and something we'll discuss today. Additionally, that what if developer rejects your bug report? That happens pretty much in every project. Developer is going to reject your bug report. What are you going to do? Are you going to send it back right away? Or so you see, that is a tricky question, tricky situation, and that's normal. And there's usually a reason why developer would reject your bug. Here's another situation. They might think that, okay, it sounds like a good finding, it sounds like a good bug. However, I don't think this is something that we will be fixing at the moment, right? So I don't think this has to come in the next version of the application. This is something that we're planning to fix, but in the future, not right now. In that case, the status of the bug will be deferred. Okay, the bug will be deferred to the future fix, basically. There could be a situation where several testers are working on the same application at the same time. Okay, the same application at the same time in parallel. 2 testers or 3 testers are testing, and they might actually find duplicate issues. So, you know, Ben found an issue, and then Angela found another issue, but they're the same issues basically. And then they reported both of them in the Azure DevOps or in Jira, and developers are looking at it and they say, oh, this was already reported, so it's a duplicate. Okay, now if all checks out, this is a valid defect, we need to fix it now, then developers start working on it. Okay, so it's going to be assigned to a particular developer, and that developer will start working on it, and the status will be in progress. In progress. Now, at that time, you keep testing, you keep doing your job, you have other 100 test cases to execute, let's say, you keep executing your test cases, so, and then they keep fixing. When they're done fixing, they change the status and say, I'm done fixing, so it's fixed. It's not in progress anymore, it's fixed now. And they're going to assign it back to you. So they will say, you know, if you're a tester, they will say, hey, Mark, this is fixed. Why don't you go ahead and retest it? You need to retest when it's something fixed, right? When the bug report is fixed, your job is to retest it. So when you retest, that means you're basically checking again, right? Rechecking again. If you saw an error message before, and now you're like, or am I going to see the error message again? Or is it fixed, right? If it's fixed, that's great, right? That's the end of the story. You close the bug. So the status of the bug goes from fixed to close, okay? However, that's not always the case. Again, developers are human beings. They think they might have fixed, but they didn't, right? You rerun your test, you go and check the actual behavior one more time, and then you can see that, oh, the issue is still there, right? If the issue is still there, then you reopen the bug. Okay, you reopen and then you assign it back to the developer again. It's not a pleasant moment, not a pleasant conversation in this particular case. You have to reopen, you have to put some comment and say, you know, hey, Jennifer, looks like I can still see the issue, and attach some screenshot as an evidence and let them know that I still see it. Okay, now, as you know, practice makes perfect. So let's take a look in the actual application. So let me bring it over right here. Okay, so this is a task management tool, Azure DevOps, that we were looking into yesterday. We created our test case here. Okay, we created our test case and it passed yesterday. So now we're going to see an example when the test case actually fails. Okay, we're going to see an example where we will run a test case and it's going to fail. Okay, and when the test case fails, what do? We create an issue or a bug report. So we go ahead and select the test case, and the test case is verify user can view about page. Okay, so I'm going to run for a web application. So give it a moment. So it's going to open in the left-hand side right here. Okay, and okay, it's loading. Then we will go ahead, meanwhile, take a look at our application under test, and then just put it side by side. That will be the best way of actually running your test cases. Just put the application that you're planning to test right next to the test runner, right? Test runner. So the first step, you go to this page, login page, and then login page to display. That's a pass. Okay, enter a username. So we're going to enter a username, but we're going to use, this is a test application, and you know, if you go with the problem user, you're actually going to see a bunch of defects, and that's a good thing. Okay, so that we can actually see what the defects look like, what a bug looks like. So we're going to enter a valid username. We're going to enter a valid password. Those are still valid username and valid password. And you can see that the password is masked here. It passed. That was the expectation. So I'm going to log in. When I log in, I already see some issues here. Do you see that pictures are missing? This is, you know, I logged in. Well, product list displayed, but then I see some issues. So I'm going to go ahead and I already failed this. So I would say product pictures are not displayed. Okay, so that will be a comment that you can put, and click the menu button. So I'm going to click the menu button. Menu button is working fine, and then click the about button. So I'm going to go ahead and click about button. So I was expecting an about button, about page, but what I saw was error 404, and this page is lost, or so this is an example of a lost or not found page, basically. Okay, so I'm going to go ahead and fail that too. I'm going to fail the test case, and you can see right here at the top you have an option to create an issue. So I'm going to go ahead and click create issue, and a new window opens. So a new window opens where we can start filling out information about the issue that we just faced. Okay, the first thing is the name of the bug report. Just like when you created a test case, you gave a name to your test case, right? Yesterday, we created a new test case. We said, verify user can log in with a valid username and password. But this is not a test case. This is a bug report. So we need to deliver a message, give a title to our bug report. So we can say, getting 404 error message when clicked on about page. Okay, when clicked on about page. There's actually another issue that we saw earlier that, that should be two different bugs actually. So, but we're going to focus on the about page since the test case itself was about it was about page. So we gave a name to our bug report. What's the next step? The next important, very important step that you need to look into is the steps to reproduce. Steps to reproduce. An application like this, Azure DevOps, is very, very efficient. That it actually took all the steps from the test case and then put it in your bug report, right? So you don't have to type all of this in, because the steps to reproduce is a very important piece of information in your bug report. If you just send this information, let's say, that may not be sufficient, right? So you need to tell exactly what steps you took, what type of steps, what kind of steps you took before you encountered this issue. That's what we refer to as a steps to reproduce. Okay. Now, there's a discussion section. That's where you can put some comments, and you can also put some screenshots. Like I mentioned earlier, that what we refer to as evidence, right? To take an evidence, it's always useful to use a tool such as snipping tool. Okay, have you ever used a snipping tool? So that's something that as a tester you would be using a lot. So you can go ahead and take a snapshot like this. Okay, here we go. I just took a snapshot, and you go ahead in your discussion section and paste it. Control V. That's it. Here we go. We just took our evidence and then paste the evidence there. Okay. Now, bug status, though, as I mentioned, it's when you create it, it is new. Okay. Usually it is a new, and you can assign it already to a particular developer. So if I have a developer here, for example, Oliver, I would go ahead and assign it to an Oliver, the developer here. Okay. All right. There's also other sections, information within the bug report, where you can assign how high or low priority this particular issue. So about page is not of so high priority, so I would go ahead and put like 3. So that should be fine. And save and close. Okay. And again, save and close. So we're going to go back to our test case. As you can see, our test case has failed, and the bug report has been created. Okay, the same thing. So we just like we created this bug report, the developer would actually get a notification. Developer would get a notification about that particular bug being created. So as you can see, this is the developer's perspective. Like the Oliver would see that, okay, and then it's assigned to Oliver as a developer, and they would go ahead and provide some fix, or they could change the status. You see, they can say, they can reject it, or they can mark it as duplicate, or they can say it's in progress. Okay, it's in progress, and put something like working on it. Okay, here you go. And further on, they might say fixed. Okay, it's fixed. Go ahead and retest, and they can change the status to fixed, for example, and save it. Okay, and they can reassign that back to the tester. So that's basically how the interaction happens between the tester and the developer, just like I showed you in the overall bug life cycle. Okay, in the bug life cycle. All right. Here's some examples, some additional examples of how the bug report actually looks like. So this is an example from Azure DevOps. Here's another example from Jira. You can see that bug reports are all pretty much the same. So important piece of information is to have the steps to reproduce. The steps to reproduce is very important piece of information in every bug report, so that developers know how to recreate the bug. Okay, here's another example called HPALM, or Application Lifecycle Management. Same thing. As you can see, steps to reproduce is in the bug report. Okay. All right. Now we come to the point where we can answer this particular question. So think about it. You are in a working environment, right? This is, by the way, one of the frequently asked interview question. You are in a work environment and developer rejected the bug that you just reported. What are your actions? How would you react? How would you resolve this situation? So tell me. All right. So go ahead and you can put it in the chat as you've been doing earlier. Okay. So you need to check. You need to check the comments. That is correct. Check why it was rejected by the developer. Good answer. Yes, you need to read the comments, like you see that I just showed you in the tool, in Azure DevOps tool, that there is a comment section, right? There's a comment section or discussion section where they can actually, developers would actually put some comments. And also retest and be specific about it. So that's true. Yes, you need to be specific about why it actually failed. That is true. So to summarize, you need to understand the reason for a reject. If you are asked this question, interview question, that's how you should start, right? So first thing to do would be, I will go ahead and then understand the reason for a reject. And the reason for rejection would usually be in the test management tool. If you're using Azure DevOps or Jira, in the comment section and discussion section, developers would put some comments saying, well, I'm rejecting this because I can't see it, I can't reproduce it, or I'm rejecting because I don't think it's a bug, right? So there has to be a specific reason for this. And if the reason was they can't recreate your bug or they can't see it in development environment, so then why don't you go ahead and recreate it? Try to reproduce the bug again in QA environment, okay? Now, as part of the bootcamp, we'll talk about environments for sure in more detail. So it's better to provide more evidence, okay? Provide more evidence, more information with additional screenshots and additional steps and which test users you have used. And at the end, when you collect all that information, you can organize a call, be more proactive, right? Be more communicative. So organize a call with the developer, invite your QA lead to the call, like bring a backup basically, right? Just make sure that if anything goes like into more like a tense communication, that there's someone who can actually help you out, or a higher standing manager. So always, it's good to include your QA lead or manager in the calls with the developers. It's absolutely fine. Then as a result of the discussion, you can either reopen or close the bug. You guys did great today with this particular lesson, with the bug reports. And so your participation is so active. I like it. And that's what I expect from the students. The next lesson, SQL, don't miss. That's where we're going to learn how to organize the data, how to run queries, how to create queries. So I'm going to show you a tool called SQL Server Management Studio.